GAC, how's it going? This is Coach Johnson with Algebra 3 Review. Hope you're having a great day today. I know some of you are just really excited to get past this test, this one of the final tests left in this semester, 2.1 to 2.4. Hope you're paying attention here. A couple of announcements, things that you need to look over. Make sure that with your review sheet, you're going through it. Make sure the answer sheet you understand is posted online. You could go access that at any time. If you have any questions, email me, come in the morning tomorrow or Thursday, and I'd be more than happy to help you out with that. One of the things that I also will say that I'll kind of put in the announcements is that you are allowed to have a note card tomorrow. It must be a 3x5, only one side. You can put formulas on there. You can put anything you want. If you want to, I will have the formulas posted online, whether that's the quadratics or in behavior. I will post that during the test, so feel free to do that, and we'll go from there. All right, let's start. Let's get underway. Let's start with the first question. And now let me screen share this here. The first question I want to get to is number 6. And these are all the ones that I took from questions you had in class. So as I go through these, some of them you might really use there. So this one says 1 minus I all over 3 minus 2i. Well, remember, anytime I have an I on the bottom or on the denominator of a fraction, I want to get rid of it there. And so in doing that, we want to rationalize it, kind of like what we did with square roots there. And in doing so, let's multiply by the conjugate of 3 plus 2i. 3 plus 2i. So again, we're going to change that middle there. And so when I do it on the top, remember we were multiplying 3 times 1 to get 3, 1 times 2i to get 2i, and then negative I times 3 to get negative 3i, and negative I times 2i to get negative 2i squared. So we'll keep that right there up on the top. Now let's look at the next one. The next one's 3 times 3, which gets me 9. 3 times 2i gets me 6i. Negative 2i times 3 is negative 6i, and negative 2i times 2i is negative 4i squared. So we have a canceled here. We know that on the top we'll have this I squared turns into negative 1. So does this one on the bottom. So that just simply changes the sign. So now we've got plus 2 here. So 3 plus 2 would get me 5. 2 minus 3i is negative I. So I have 5 minus I on the top. And on the bottom, negative 4 times negative 1 is 4. That's 4 there. And so 9 plus 4 is 13. So you can either write it just like that, or you could write 5 over 13 minus 1 over 13. Or you could say minus I over 13 rather. So the 13 goes to both. I'll take either or as my answer there. Check out this next one. All of these, by the way, as I check the test right in front of me, all of these will be used on the test. So these are great questions that we can use come test time. One other thing that you could also apply is if you have a negative inside of a square root. In that example, what you could do is take that and end up saying that it's I square root of 2, and then over here on the right side I could get 3 plus I square root of 8. So when I multiply 2 times 3 and 2 times I square roots of 8, I'll get 6 plus 2I square root of 8. Negative I square root of 2 would be negative 3I square root of 2. And then negative I square roots of 2 times I square roots of 8 would end up being negative I squared square root of, and then multiply on the inside, 8 times 6 would get me 16. You can kind of simplify. 6 is already simplified. This 8 right here, remember, would be 2 times 2 times 2. So I could take out a pair of 2's to the outside to get me 4i square root of 2. So right now I've got 6 plus 4i square roots of 2 minus 3i square roots of 2. And then remember, square root of 16 makes it easy. That'll be 4. So it'll be minus 4i squared. What does I squared turn into? Yes, I hear you at home, negative 1. And so 6 plus 4, because this would be positive 4 here, 6 plus 4 would be 10. And 4i square roots of 2 minus 3i square roots of 2 would be positive I square roots of 2. So 10 plus I square roots of 2 would be my ultimate answer. Hope that was easy for you going forward, all right? Again, that was number 10. Check out this next one. The next one we're going to look at is number 14, and it's determine whether number 14 is a maximum or is it a minimum. And what it has is g of x is equal to negative 3x squared plus 6x minus 4. So with my vertex will be negative b over 2a. Well, b is 6, so we'll have negative 6 over, and remember a is negative 3. Make sure you take that sign there. So 2 times negative 3. So negative 6 over negative 6 equals positive 1. Well, in finding my vertex, you might say, well, coach, how in the world am I finding what my maximum or minimum is with my vertex? Well, think of it this way. If I have a graph and this a is negative, what's happening to the graph? You're right, shooting downward. So because of that, we know that this top or the vertex is going to be a maximum at this point. Well, we know that our first step is getting that x in our vertex, which is 1. And in order to find the y, we plug 1 back in for my equation. So then I'd have g of x equals negative 3 times 1 squared plus 6 times 1 minus 4. So 1 squared is 1 times negative 3 is negative 3. Negative 3 plus 6 minus 4. As I combine it, negative 3 plus 6 is 3. 3 minus 4 is negative 1. So my point would end up being 1 comma negative 1. That's my vertex. And again, whether it's a maximum or minimum, I know because this is negative, it is going to go downward. Therefore, I know my maximum would be where my vertex is, which is at 1, negative 1. And again, all of these problems are ones that will be on our test there. All right. Take a look at this next one, 3x to the 4th plus 5x squared minus 2x plus 1. And I'm going to put another one down here. I'm going to look at number, that was 15. Let's look at number 18 here. Number 18 will be 2x to the 3rd minus 4x squared plus 7. All right, so let's do this. Let's minimize all this. Let's minimize here. And it might come back up to me, but that's okay. I'll pull it up in just a second. You hopefully should have that formula there. And that's what I'm looking for here. Looking for that formula sheet. I might need to pull it up online here. Let me pull this up. See if we got it on here. Let's see, we got it here. And again, all I'm doing right now is trying to pull up the end behavior formulas. Again, you can do that too. It should be on your notes under 6.2 or 7. I'm sorry, 2.2. 2.2. You should have that going forward. Awesome, right here. And so all I'm doing is trying to take that offline and put it right there. All right, excellent. Screen share. There we go. Put that right here. Excellent. All right. So screen share this bad boy one more time. There we go. So as I look at this, there are two things I'm looking for. First, is my degree highest exponent, right? That's the highest exponent. Is my degree even or odd? If it's even, I'm looking here. And if it's odd, I'm looking here. So I know that number 15 is even, so I'm going to look right here. And I know that my lead coefficient, if it's positive, I'm looking this way. Kind of make sure I do it. I'm looking here. And if it's negative, I'm looking on this side. So I've just got to match up what's true here. So I know my lead coefficient is positive. So I look across, and I know that my highest degree or my highest exponent, my degree of my polynomial, is even. So I know that it's at this spot. Well, where do they coincide? Well, it should be right there. It should rise to the left and rise to the right. All right, so I've got that, number 15 there. Check out number 18. Number 18 has the same thing. Is my lead coefficient, and I'll do this one, let's do it in green here. Is my lead coefficient, which is the number in front of the highest degree, is it positive or negative? Well, it's positive, so I know I'm going to be there. And then is my highest degree, highest exponent, even or odd? Well, since I know it's odd there, and I know that the lead coefficient's positive, I know that I'm going to be right here, meaning I fall to the left and rise right. Fall to the left and rise to the right. So I have that one as well as that one right there. Okay, try number 16 and 17 out And if you need some more help, ask me, and I could go over that before the test into tomorrow. Check the next one. We've got number 19. We'll do number 19 and a couple on the back, and we'll be done. Number 19 says g of x equals x squared minus 4x minus 1. Now, in this example, it tells us to graph the quadratic, and it can kind of get tricky because we've got about 3 or 4 different things we've got to find. We've got our vertex, y-intercept, x-intercept, and then we've got to graph it. So all of these things are things that we need to do before we start graphing. So as I'm kind of putting these lines here, we know that to find the vertex, just like we did before, we do negative b over 2a. So negative b over 2a would be my vertex. And in plugging in, I should get minus negative 4 all over 2 times a. A should be 1. So 2 negatives make a positive. So 4 divided by 2 gets me 2. So I've got 2 for my vertex on this one. Now, how do I find my y? Well, simply, I plug 2 in for x. So I'll have 2 squared minus 4 times 2 minus 1. So 4 minus 8 minus 1 should equal negative 5. So negative 5 should be my y in my vertex. So I'll go 2 to the right, down towards negative 5. Another thing you might want to find is also your a. Is it going up or down? That might be helpful to do next there. Okay, so we know that it's at 2, negative 5. My a is positive, therefore I know it's going upward. It's going up. And we know it's at 1, so it should be rise 1 to up, rise 1, run 1, rise 1, run 1, at least for my first 2 there. Okay. Next part is to find the y-intercept. Remember, the y-intercept is always my c. It's always 0, c. C is negative 1, so it should be 0, negative 1 is my y-intercept. My x-intercept can be found by factoring. Now, on the test, I'm going to just tell you, you could factor this and be able to solve for it. Absolutely can. But in this example, you're going to have to do the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be minus negative 4 plus or minus the square root, negative 4 squared minus 4, and a times c. A is 1, c is negative 1. And it should go all over 2 times a. And a would be 1 here. So when I simplify this, I should get 4 plus or minus the square root, and this should be 16. This should be 4, so 16 plus 4. So 4 plus or minus the square root of 20, all over 2. And if I were to simplify this right here, the square root of 20, I could use one of my charts here to get 4 and 5, 2 and 2 to get a little pair of 2's to the outside, to get 4 plus or minus 2 square roots of 5 all over 2. So divide all 3 of these by 2, has to be all 3 there. And when I do that, I'll get 2 plus or minus square root of 5 all over 1, or just say 2 plus or minus the square root of 5. Now, because we can't do that, I'm going to get my calculator and actually plug that in. So do 2 plus square root of 5, and then also 2 minus square root of 5 to see what we get. So 2 minus square root of 5 would be negative 0.24. So negative 0.24 there. And again, this is going to be a little bit easier on the test. It's going to be a little bit nicer. But we'll just say it right now. X is equal to negative 0.24. And the other x, when I do plus, would be 2 plus square root of 5. Do this. 2 plus square root of 5. All right. 4.24. All right, 4.24. So right now I've got negative 0.24 and 4.24 as well. So over here, 1, 2, 3, 4 would be right here, right in that area. 0.24 should be about right in that area. So it should come down, touch, come straight back up. I have my y-intercept, 0, negative 1. X-intercepts are down here below, and you could put it as, really the mathematically beautiful way is to put it as that, comma 0, and 4.24, comma 0 as well. All right. So those are what I would do for number 19. It's a pretty tough one, but again, very doable going off of that. Okay, let's do 20 now and 21. Now, both of these are the exact same thing. The only difference now is on 21, you actually have to factor it, whereas 20, it's given to you. X minus 7 to the third and x plus 4 to the second power. Now, what are my zeros of my graph? Well, my zeros would be whatever would make both of these equal to 0 here. And so I have one, x is equal to 7, negative 4. And again, remember zeros are the same as x-intercept. So we have x is equal to 7 comma negative 4, but we could also say 7 comma 0 and negative 4 comma 0 would be the appropriate way to write that. Now the next question is, after this example, at each point, does it touch or does it go through? Well, first let's find the multiplicity of each. Remember, that's how many times it's repeated. So because the 7, 0 is repeated 3 times because it's to the third, my multiplicity would be 3. What about negative 4, 0? Yeah, you're right. It would be 2. So the multiplicity actually determines whether it's going to go through the x-intercept or x-axis, or if it's just going to touch at that x-axis there. So if you look at 3 here, at 3, because it is odd means that it's going to go through. So it's going to go through the x-axis. And 2, because it's even, means that it's going to touch and go on the x-axis. So think about it. If you had x squared, what does x squared do? Yeah, x squared just touches and then comes back. Whereas something that's cubic actually goes through that graph. So x cubed, because it's odd, goes through, whereas x squared touches and returns. Now the next one, 21, is x cubed minus 8x squared plus 16x. Well, what's in common? Well, the thing that's in common is an x. So if I take out an x, I have x squared minus 8x plus 16. So what two numbers, when multiplied, give me to 16, but when added equal negative 8? Well, my only answer would be x minus 4 and x minus 4. Well, if I were to rewrite this, I could say x times x minus 4 squared. So what are my two zeros? You got it. X equals 0, comma 4. And because the multiplicity of this first one, because the first power is 1, and because it's x minus 4 to the second, multiplicity of this would be 2. So my multiplicity would be 1 and 2. Because it is odd here, it's going to go through the x-axis, and because this is even, it is going to touch at the x-axis. All right, hopefully that makes sense to you. Hopefully we're moving forward from that. All right, number 25, and Ashley, I know you had 24. If you want to come on in tomorrow morning, I'd love to do number 24 with you. I might have some time at the end to at least touch on it, but 25 is one that I just can't pass up. 25 is a really good one. The one that we're getting at is 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. And remember, if I didn't have one of those spots, I have to fill it in with a plus 0x. All right, now the denominator here that we're dividing by is x squared plus 2x minus 3. And remember, my question remains the same every single time. So the pattern is always the same. What times all of this, or what times x squared gets me to 2x to the fourth? Well, there's only one thing, and that's x squared. So x squared times x squared gets me x to the fourth. And it should be 2, I'm sorry, 2x squared. 2x to the fourth. 2x squared times 2x should be 4x to the third. And 2x squared times negative 3 is negative 6x squared. Well, what do I do next? You're right, we change the sign here. Change the sign here, change the sign here, to where this one cancels, and over on this right side, this should just be x squared. Also, we're going to bring down this 3x here. So I have x squared plus 3x, but remember, since I have 3 of these, I'm also going to need a third one since both of these got canceled. A little cancel party there in honor of Thanksgiving. Obviously, not Christmas. Who would ever want Christmas? That's fine. I mean, who would ever want Christmas? All right, so the next question is, same thing. What times x squared gets me to x squared? Yep, you're right. It would only be a positive 1. So 1 times all of that would be x squared plus 2x minus 3. And as I change the signs of these, you'll start noticing quickly, this cancels, leaving me with x. This should be a plus 3 there. I apologize. And this should be x plus 1. Since there's nothing else to bring down, what I can do is say 2x squared plus 1, remainder x plus 1, or you could say 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. All right? All right, so I hope that was helpful for you on 25. If you need some more help on that, please come in. Remember the big thing, what on top times this, times x squared gets me to my first coefficient and my highest degree within my polynomial. Also, there will be no remainder theorem. There will be one very similar to 25. There will be one very similar to really a lot of these. All the ones I've went through are ones that will be on the test. There are no questions about that. All will be on the test. Just make sure that you're there. But remember, there will be no remainder theorem on the test going forward. All right. Last but not least, let's do this one. F of x equals x cubed minus 2x squared minus x plus 2. Now, I know that they've given that 1, 0 is -1, and they say find all other zeros. Find the zeros. Well, I know that if -1 fits into my box neatly and nicely, I also know that the numbers that are here from the greatest to the least, if I put alongside of it, I could find out if this was a 0, I could use that to help myself find out what the other zeros are. So I would have 1, -2, -1, and 2. So with the first number, I bring her down. So I'm going to multiply -1 times 1 to get -1 there. Then I'd have -3 after I combined. Multiply -1 times -3 to get 3 there. Combine. 3 minus 1 is 2, or -1 plus 3 is 2. 2 times -1 is -2. And 2 minus 2 would get me 0. Remember, this is my remainder. The next is by itself, the next has an x, and the next has x squared. And remember, if it says that it has a 0 as my remainder, that is basically what it's telling me, that this value, this -1, is certainly a 0. So now I'd have x squared minus 3x plus 2 equals 0. So when factored, I would say what two factors when multiplied get me negative or positive 2, but when added equal -3. There's only one, x minus 2 and x minus 1. So when I set those equal to 0, x will be equal to 2, 1, and don't forget that last one, the one that we used at the top, the one that was given to us, -1. Again, I hope this was helpful for you. Again, 24 I could kind of do before the test, but the ones that you're really going to want to look at, number 6, I mean all of them. I mean all of these are good. 6, 10, 11, know how to do the quadratic formula and behavior. Number 19, also I'll give one where you'll have to graph this right here, x plus 1 squared plus 2. Maybe with a negative, you'll need to know how to graph that. You need to know also synthetic long division. You'll need to know multiplicity and behavior. You'll also kind of, if you desire to do so, with the graph here, if you were coming back to this one, I know that I have a graph at 0 that will go through 0 and 4, okay, because remember we're talking about this. So because of that, if at 0, I'm literally touching and going, okay, one way or another. And to find out what's happening with this, if I go back to my chart with x cubed, remember x cubed, it'll kind of tell me at x cubed, we know the degree is odd, and we know that it's going to be positive, so it's going to go fall left and rise right. Fall left and rise right. So if it falls left down here and it rises up here, I know that as I come to this, I can go upwards here. It's going to go through. All right, it's going to go up somewhere. It doesn't matter where. I know that it's going to touch, but we know that ultimately it will go back up again. And you might say, how do I know that? Remember with the chart, with the fact that it was x cubed, I know it's going to fall to the left and rise to the right. And again, this is going to be a bonus, only a bonus on this one for the test. Again, I'm hoping that that was helpful for you. I know it was very quick there, but I was trying to just at least give you some chance to review over. Let me do this. Let me go through them. If you feel like you need to pause them at any time. Feel free to do so, and we'll go from there, all right? Feel free to pause them, and I'll sing somewhere over the rainbow, way up high. Don't call me Munchkin at school tomorrow, please. Tell you what, you put Munchkin on my on the test tomorrow, I'll fail you. I'll fail you. Yeah, David and Thomas, just going through right now. Take a picture of it, but I'm not a Munchkin. I'm quite taller than them. So thank you very much. All right. Hopefully that was helpful for you. I know we had a lot we went through tonight. Again, if you have questions, feel free. Come by tomorrow after school. And other than that, have a happy Thanksgiving. What's that? Hold on, someone wants to say hi. Hold on, just. Have a great day. Bye now.